Hi students, welcome to another video. So we already discussed example 7 and 8, and today the example is 9 of exercise 1.1. Okay, so what is given? You see the example in your textbook. So what is given? 60 students of a class which have 90 total students 90. 60 of them play volleyball. Okay, so 53 play badminton and 35 play both the games. Okay, so we have to find how many students do not play any game. Okay, and how many play badminton only but not volleyball, and how many play volleyball but not badminton. That means badminton, volleyball only. Okay, and 4 is what? How many students have played at least one of two games. Okay, so first we take two sets. Suppose this is A set and this is B set. So this is A and this is B. We take A as the set of students who play volleyball. Okay, so this is the set who play volleyball, and this is the set who play badminton. Okay, so what you have given, there are total 90 students, and here is not given that all the students have played uh, any of games. Okay, so there we have to write the universal set U. Okay, so students who do not play any games, they will remain in this part. That means out of A union B. Okay, so take let A is equal set of students who play volleyball. Okay, who play volleyball. And B, what is B and B? Set of students who play badminton. Okay, who play badminton. So from figure we can find it. So see here, 60. See here, 35 of students play both of the games. That means in this part, this is A intersection B, and in this part there are 35 elements. Okay. So how this is the A set is what? A set is set of students who play volleyball. Okay. So how many students play volleyball? 60 play volleyball. Okay. So in this part, the this is A difference B. So in this part, what is the number of elements? 5, 5, 3, 2. That means there are 25 elements in this part. Okay. So then we will get this is 60, 5, 5, 0, 2, 3, 5, 6. That means in this part there are 25 elements. Okay, and what is given? 53 of them play badminton. So B is the set of students who play badminton. Okay, so in these 35 students play both volleyball and badminton. Okay, so what is given? 53 total 53 students play badminton. So we get in this part we get 53 minus 35. That means 8, 4, 3, 1. That means 18 students. Okay, so 18 students in this part. There are 18 students. Okay, so what is given? We have to in first case we have to find how many students do not play any one of games. That means elements in this part out of A union B. So A union B will whole this part is called A union B, and it is what? 5, 5, 10, 10 plus 8, 18. Okay, and 2, 3, 5, 5, 1, 6. 2, 3, 5, 5, 1, 6, 6 plus 1, 7, 78. That means 78 students play at least one of the two games. Okay, so how many students will not play any games? We find, so we subtract this number 78 from 90 total students. Okay, so 10, 8, 2 and 1. That means 12 students do not play any of the games. That means in this part there are 12 elements. Okay, so now we get what now? N is equal what? N is equal number of students who play volleyball. So this is 60. And B is equal what? Number of students who play badminton, and 35 students play both of the games. Okay. So N A intersection B is equal what? N A intersection B is equal 35. And here N is equal what? N is equal 90. Okay. So now by formula we get what? Now N A union B is equal what? N A union B means what? N A union B means number of elements in this part, all this part. So in this part, students who play at least one game will, at least one or both two games will remain here. Okay. So N A union B is equal N A plus N B minus N A intersection B. So N A is equal what? N A is equal 60. And B is equal 53 and A intersection B is equal 35. So what we get? 3, 6 plus 5, 11. 1, 1, 3. Okay. And this is 35. So what we get? Okay. 3, 6 plus 5, 11. What we get? 8. And this is 7, 78. Okay. That means 78 students play at least one or both games. Okay. So in first case we have to find what? How many students do not play any of games. Okay. So we write here. So number of students who do not play any game, is what? NU minus NA union B. That means what? 90 minus 78, and this is what? 2 and here 1. So there are 12 students who do not play any games. That means in this part out of A union B, but inside of U there are 12 elements. Okay. So now we have to find in question 2, how many students play badminton but not volleyball. That means what? We have to find a number who play only badminton. That means number of elements in this part, and we get it is 18. Okay. So we have to find, actually we have to find N B difference A. This part is called B difference. So we get this NB from whole set. We subtract this part NA intersection B. So what we get? NB is equal what? NB is equal 53 and A intersection B is equal 35. That means what? This is 18. So it is very easy. And third is what? How many students play volleyball but not badminton? That means number of elements in this part. This part is what? A minus A difference B. And this number is 25. Okay. So we have to find N A difference B. So by formula we subtract from the whole set A. We subtract N A intersection B. Okay. So N A is equal what? N A is equal 60 and N A intersection B is equal 35. That means what? 5 and 2, 25. That means there are 25 students who play volleyball but not badminton. Okay. And now see what is given in fourth example. How many students play at least one of the two games? That means at least means what? How many students play only one game or both two games? And the answer is what? The answer is 78. That means we have to find in example 4, we have to find NA union B, and it is we already found 78. Okay, you see the example 10 in textbook. So what is given? It is very easy. What is given? In a survey, 1500 families, between 1500 families, 1263 have TV. Okay, 1263 families have TV, and 639 families have radio. Okay, and 197 families have nor TV, neither TV nor radio. Okay, so what we have to find? We have to find how many families have both TV and radio, and how many families have only TV but not radio, and how many families have only radio but not TV. Okay, so see here, suppose this is you number of all set of all families. Okay, so in this, and A is the set of families who have TV. Okay, and B is the set of families who have radio. Okay, and in this set, that means in universal set, there are 1500 in whole part. In whole part, there are 1500 elements. Okay, but 197 families have no TV and no radio. That means what? Uh, in this is A union B, this is A union B, and in this part only those elements will remain who have either TV or radio or both. Okay, so 197 elements remain outside of A union B but inside of U. Okay, so from this we get what? From this we get N A union B. Okay, see here, take let A be the let A be the set of families who have TV. Okay, and B be the set of families who have radio. Okay, so we get what? We are given N is equal what? N is equal 6. N is equal what? N is equal 1263. That means 1263 families have TV. Okay, and what is given? NB is equal 639. That means 639 families have radio. Okay, and what is given? 197 families have no TV, neither TV nor radio. Okay, so first we have to find N A union B. So N A union B is equal what? N A union B is equal NU minus 197. That NU is equal what? NU is equal 1500 and 197. 0, this is 3, 1. That means 1303 families have either TV or radio or both. Okay, now see what we have to find. We have to find the number of families who have both TV and radio. That means we have to find the number of elements in this part, and this is what? This is N A intersection B. Okay, so first we get we write N A. We know what? N A union B is equal what? N A plus N B minus N A intersection B. Okay, so you get N A union B is equal 1303, N A is equal 1263, N B is equal what? 639, and this is N A intersection B. What you get? 1303. Add this, 3 plus 9 12, 6 3 9 10, 2 6 8 9, and 1. Okay, minus N A intersection B. So what you get? You get N A intersection B. We transfer this from right side to left side. Okay, and 1902, and we transfer this from left side to right side. So sign will be negative, and what we get 9, and here 9 also, and here uh, 5. Okay, so 599 families have both radio and TV. Okay, now we have to find how many families have TV but not radio. That means we have to find the number of elements in this part. This is A difference B. So we write N A difference B is equal what? N A minus this part. This part is what? N A intersection number of elements in this part. Okay. So N A is equal, you get what? N A is equal 1263, 1263, and A get what? N A intersection B is what? N A intersection B is 599. So what is the answer? What is the answer? We get 4. Here we get 6, and here 6. Okay, that means 664 families have only TV but not radio. Okay, and now what we have to find? We have to find how many families have how many families have radio but not TV. That means how many families have only radio. That means number of elements in this part. This is B difference A. Okay, so we write N B difference A is equal what? B minus N A intersection B. Okay, here NB minus NA intersection B, and A intersection B is equal what? 599. That means answer is what? 990, and this is 40. That means 40 families have only radio. Okay, that means have radio but not TV. So if you find the video helpful, please subscribe my channel, and thanks for watching, and bye bye for next class. Okay.